Have you ever really stopped to wonder what an AI reads to get so smart? It's not magic. It's actually a diet, a massive and often very secret curriculum of text. So today, we're going to pull back the curtain and unpack the hidden library that shapes what these models know, what they can do, and why it's one of the most guarded secrets in all of tech.
We talk a lot about the AI models themselves, their size, their architecture, but the real secret sauce? It's the data. As this Stanford lecturer puts it, and it's a great hot take, data is the most important thing. It's the foundation for literally everything an AI becomes. So that brings up a huge question, right? If data is the absolute key, why are the big tech companies so cagey about what they're using? Well, the answer is a mix of super high-stakes competition and, frankly, trying to navigate a legal minefield that could blow up the entire industry. So where did this whole journey begin? Before this data gold rush made everything so secretive, things actually started in a surprisingly clean and, you could say, curated place. Let's take a look at the very first textbooks that were handed to these early AI models.
Okay, so back in 2018, you had models like BERT, and its library was pretty small and high quality, about 7,000 ebooks plus all of English Wikipedia. Pretty straightforward. Then a year later, GPT-2 got a bit more creative. Its creators built this dataset called WebText, and they used Reddit as a kind of human-powered quality filter. They had this clever idea to scrape web pages that were linked from Reddit posts with at least 3 upvotes, or karma. The bet was, hey, if people find it interesting, it's probably good stuff for an AI to learn from.
But just a curated slice of the web? That wasn't going to cut it. The ambition grew way, way bigger. The goal became training an AI on, well, everything. And that meant moving beyond the nice, tidy corners of the internet and figuring out how to tame the entire wild, messy web.
And that's where Common Crawl comes in. It's a nonprofit that basically takes a snapshot of the web every single month. It's the closest thing we have to a public library of the internet. Now, here's the catch. It is enormous, it's totally raw, and it is full of junk. We're talking duplicate pages, spam, you name it. This creates a massive challenge. You've got this colossal digital haystack with trillions of tokens, and tokens are just pieces of words. How in the world do you find the few needles of high-quality text in all that noise? Well, this problem led to 2 totally different philosophies for how to clean it up. All right, so the first approach is pretty simple, rule-based filtering. Think of it like a bouncer at a club with a really simple checklist. Does the sentence end with a period? Check. Are there any bad words on the page? Nope. Okay, you're in. It's fast, but it can let some real junk slip through. The second approach is way more sophisticated, model-based filtering. Here, you basically train one AI to act as a quality judge for the text, asking, hey, does this look like something from Wikipedia? Now, this is great at finding well-written stuff, but it has a big risk. It can become biased and start throwing out perfectly good text like recipes or poems just because they don't look like an encyclopedia entry. So all of this led to the modern approach. People stopped searching for that one single perfect source of data. Instead, they became something like master chefs, realizing that the real key was to artfully blend a bunch of different ingredients.
The goal became crafting a balanced data diet. It's just like for a person, right? You can't just eat sugar all day and expect to be healthy. An AI needs a variety of text. It needs factual articles and conversational Q&As and logical code to develop a really broad set of skills. A perfect example of this is a famous open-source data set called The Pile. Because it was public, it gave us all a peek into what a big-time data diet looks like. And you can see it's this carefully crafted mix. Yeah, it's got web text from Common Crawl, but it's balanced with academic papers, a ton of books, code from GitHub, and even Q&A forums like Stack Exchange.
And when you dig into the ingredients, you find some really wild stuff. I mean, sure, you've got public domain books from Project Gutenberg. That makes sense. But then you have Books 3, which is this controversial shadow library of almost 200,000 modern, copyrighted books. You've got code from GitHub, which a lot of people think teaches AI how to reason logically. And then there's the infamous Enron email dataset, one of the only big public archives of real human emails that even exists.
And that mention of a shadow library brings us to the giant, flashing red light issue looming over this whole field: copyright.
Here's a fact that might surprise you. The vast majority of stuff on the internet, over 90%, is copyrighted by default. You don't even have to put the little C symbol on it. If you create something and post it, legally, it's yours.
So how on earth are these AI companies using all of this material?
Well, their entire legal defense, the shield they're holding up, really hinges on one single concept: fair use. It's a part of US law that says, yeah, sometimes you can use copyrighted work without permission, but only under very specific conditions. When a court has to decide, they weigh four main factors. First, what's the purpose? Is it for profit? And most importantly, is it transformative? Does it create something totally new? Second, what kind of work was it? Factual or super creative? Third, how much of the original did you use? A snippet or the whole thing? And finally, the big one. Does your new thing hurt the market for the original work? This is the legal battleground where the future of AI is being fought right now.
Okay, so after all that reading, the web, books, code, the whole shebang, how does an AI go from being this huge silent library of knowledge to a helpful chatbot you can actually talk to?
Well, the process works like a giant funnel. At the top, in the pre-training phase, the model just ingests trillions of tokens from the web and books. This is like it's reading every book in the library just to learn grammar, facts, and basic reasoning. Then you move to the middle, for mid-training. The dataset gets smaller, billions of tokens now, and much higher quality to teach it specific skills, like math. And finally, at the very narrow bottom of the funnel, it's fine-tuned on just a few million hand-picked examples of conversations. This is where it learns how to actually be a helpful instruction-following assistant. In that final stage, that post-training, it is absolutely critical. It's the magic that transforms a base model, which is basically just a very fancy text completion machine, into an instruct model like ChatGPT, which can actually understand what you want and follow your commands.
The whole philosophy is summed up perfectly in that Stanford lecture. It says, sure, the lines are blurry, but the basic idea is clear. You start with large amounts of low-quality data and train on smaller amounts of high-quality data towards the end. It's all about refinement, from this raw, messy ocean of knowledge down to a polished, helpful conversationalist. So in the end, it really is this simple. An AI is what it eats. Every skill it has, every bias it shows, every answer it gives, it's all a reflection of its data diet. And since that diet is mostly curated in secret by just a handful of very powerful companies, it leaves us with the biggest question of all. Who gets to be the librarian for our digital future? And what happens when we don't even know what's on the reading list?